Hello, can you find all the values of x in this nice math expression? X to the power of 3 equal to I. I want you to take a pause on this video and then try solving this to see if you can truly get the solutions. If you can't, then join me as we look for it. To find this, we are going to first of all consider this expression x to the power of 3, taking the I to the right left hand side will make the whole equation to be equal to 0. Great. So from here, what do we do? I'm going to look at what manipulate this to give me this plus negative I equal to 0. I've not changed anything because plus times minus will still give me a negative I. Now I want you to recall the law of complex numbers. In complex numbers, I is definitely equal to the square root of negative 1, right? So that means I square can simply be equal to negative 1. Because if I have to square this, then I square will cancel out square root, then I will be negative 1. Now come to think about it. If I have the value of I square multiplied by I, this will simply give me I square is negative 1 multiplied by I, right? So according to indices, I square multiplied by I to the power of 1 will give us I to the power of 3, and this will be equal to negative I. So you see, this expression is very important and unique. That means negative I can be replaced with I to the power of 3. So I'll have that expression to become x to the power of 3 plus I to the power of 3, and this will be equal to 0. Great. What a unique expression. Now this expression looks definitely same as this algebraic expression to the power of 3. A to the power of 3 plus b to the power of 3, and this will give us what? A plus b multiplying a square minus ab plus b square. Now in this case, a is equal to x, and then b is equal to I. So that math expression is going to give us x plus I, right? And this will be multiplying x squared minus ix plus I square, and all this will be equal to 0. Great. Now at this point, we are going to, having approached this zero product rule, we are going to separate those expressions. And if we separate those expressions, we'll have x plus I to be equal to 0. At the same time, we'll have x squared minus ix plus I squared to be equal to 0. Now from this point, you see that x will be equal to negative I. So we're going to take this as the first solution, which is x what? x1. So from those expressions, x1 is equal to negative I. Now let's come to this other side of the equation. Considering I square, you recall what I square is. I square is equal to negative 1, right? According to complex number. So that expression will give us x squared minus ix minus 1 equal to 0. And this expression looks straight up like this algebra, like this quadratic expression plus bx plus c equal to 0. Great. Now from here, with great comparison, if we compare these two expressions, you see that our a is equal to 1, our b is equal to negative, our p is equal to negative I, right? And then our c is equal to negative 1. Now using the quadratic formula, we'll have the value of our s to now be equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2 multiplied by a. Now insert those parameters into this expression. We're going to have the value of our x to be equal to negative multiplied by negative I, right? Plus or minus the square root of negative I all squared minus 4 multiplied by 1 multiplied by negative 1, and all of these will be divided by 2 multiplied by 1. Great. Now from this expression, we'll see that the value of our s is equal to negative multiply negative will give us I plus or minus the square root of negative square is positive, I square is simply going to give us negative 1, right? So we'll have our negative 1 minus 4 times minus 1 is going to give us plus 4. 4 times 1 is still equal to 4. And this is going to give us 2. Great. So the value of our s is simply equal to I plus or minus the square root of negative 1 plus 4 is simply going to give me 3 divided by 2. So from here, you can see that having gotten our x1 to be equal to negative I, we can get our x2 to be equal to I plus square root of 3 divided by 2. Complex solution indeed. And then our I3, our x3 is simply going to give us I minus the square root of 3 divided by 2. And these are all the possible values of x that satisfy that expression given to us up there. Now remember, we are asked to find all the values of x. So those values of x satisfy this mass expression given to us up there. I know you did enjoy watching this math solution. Don't forget to give it a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified math content. Thanks so much for watching, and bye bye for now.